Good day, fellow. Today I just want us to do this concept of electronegativity. Electronegativity. See now, this concept of electronegativity, it has to do now with the tendency of atom to attract electrons to itself. You see now, the tendency of atom to attract the electrons to itself. You see, before I can even proceed with this concept, as a learner, you need to understand that we have some types of chemical bondings. You see, let me write types of chemical bonding. Do you still remember those? Chemical bond. Do you still remember those? We have a covalent bonding, a covalent bonding. We also have what? An ionic bonding. You see, we have a covalent as well as the ionic bonding. Then now we know that a covalent bonding, it has to do now with the sharing of electrons, sharing of electrons between a non-metal plus another non-metal. You see, then we also have the ionic bonding. This one, it has to do with the transfer of electrons between a metal plus a non-metal. You see now, these two, they represent what? Chemical bonding. We have a covalent as well as the ionic. Now, you also need to know that we have the bond polarity. You see, we have bond polarity. Then of covalent, we have a polar. We also have a non-polar covalent. Then the concept of polar covalent, we get a situation whereby now the atoms, they don't share electrons equally. Under polar atoms, they don't share electrons. I won't have much space. Electrons equally. You see now, we also have a non-polar covalent. Then as for non-polar atoms, they do share electrons equally. Do you understand? These two, a polar together with a non-polar, they represent what? Covalent. You see? Then we also have what? Under ionic. Under ionic, we have ions. Ions, we get a situation whereby now they transfer electrons. See? For an example, from a metal to a non-metal. Then this bond polarity is for the ionic compound. These two, they represent what? The bond polarity for the covalent bond. Do you understand? Then now, I'm going to give you a situation. I'm going to give you a situation whereby now I ask you this question for H2. Let me consider H2. Then I'm going to ask you to determine the type of bond. The type of bond and also the bond polarity. The bond polarity for this given compound. Oh, sorry, for this given diatomic molecule. You see? Then how then are you going to figure out the type of bond as well as the bond polarity for the given? We know that the structural formula for this is going to look like this. You see, we have a non-metal here. We have a non-metal. We also have a non-metal. By now we know if we have two non-metal, then the bond that is going to be formed there is going to be of what? Of covalent bonding. Do you understand? Then now, as for bond polarity, we are going to take the electronegativity for each, which is hydrogen in this case. You see this number, it represents what? The electronegativity of what? Of hydrogen. Then we are going to say electronegativity of the first hydrogen, which is 2.1. We take the difference minus of this one, 2.1. Clearly we are going to get a number of 0. You see? Then in order for us to determine the bond polarity, we are going to use this scale as a guide. Bond polarity, we are going to use this scale. Any value between 0.5 included up until 1.9, such is going to be a polar covalent. Then a value which is above 1.9 is going to be of ions. Then a value which is below 0.5 then is going to represent a non-polar. Then as for this one, we got a number of 0. It is clear that 0 is below 0.5. Then the bond polarity for this given is going to be non-polar, like this. Do you understand? Then now, let us consider another example. Suppose if now I have HF like this. You see? we know that the structural formula for this is going to be something like this. You see? Then sorry, let me erase here as well. We know that hydrogen is a non-polar, sorry, it's a non-metal. Fluorine, it's a non-metal. Two non-metal, they form what? A covalent bond. Then we are done with this question. Let us try to answer the second one. Then we know that the electronegativity for H is 2.1. Of fluorine is going to be, I hope you can see over here, it's 4.0. Let me write 4.0. Then now for us to determine the electronegativity, we are going to determine the difference between these two numbers. Let us consider the bigger number first. Subtract by the smallest number. Then we take our calculator and say 4 minus 2.1. We get 1.9. Then we get the value of 1.9. You see, this is our value now. Let's see. Then this is our scale. Any value from 0.5 along till 1.9 is going to be a polar covalent. You see now? Then now, as for the polarity for this one, it's going to be a polar, since we got a value of 1.9. You see? Then let me continue as well by looking at this one. Let us try this one. Suppose if we have now KCl, we have potassium like this and chlorine like this. Do you understand? Then we know that this one is a metal, this one is a non-metal. If we take a metal together with a non-metal, we get an ionic bonding. Then now, as for the bond polarity, let us consider our electronegativity for K is going to be 0.8. For Cl, it's going to be the value of 3 over there. It's 3.0 like this. Then now we take this and determine the difference. Then we have 3.0 minus 0.8. Then we are going to write electronegativity like this. Then let us say 3 minus 0.8, 3 minus 0.8, we get 2.2. The value of 2.2. Where does 2.2 situated in our scale? This value, it is above 1.9. Clearly is going to be ion. You see, it's going to be an ion. The bond polarity for this one is going to be an ion. You see? Then now let me give you another example. Let's say if now I were to give you this example of H2O like this. We know that the structural formula of this by now is going to be something like this. we have a non-metal, non-metal, and non-metal. All of them, they are non-metal. Then it's going to be a covalent bonding. Then now, for us to determine the bond polarity, we just need to go to our periodic table and try to determine the electronegativity of each. Then we know now for this one it's going to be 2.1, same for this one 2.1. Then for oxygen we get a value of 3.5. 3.5. Then the value for this one is going to be 3.5. Then the questions want us to determine the bond polarity. You see, we just need to figure out the bond polarity between H and O. We have the same thing, H and O. We can consider this side. You see, since we have the same thing, this side we have H, in the middle we have O. We can just consider this 3.5 subtract with 2.1 of only 1, because now we only want the bond polarity for H and O. You see, then at this point you can then take your calculator, take your calculator and say 3.5 minus 2.1, 3.5 minus 2.1, we get the value of 1.4. 1.4. You see, this value is between 0.5 and 1.9. This means that the bond polarity of each is going to be of what? Of polar now. Like this. Then we have managed to solve this problem. I thank you, fellow, and enjoy your day.